How's our transparency now? We put the transparency over it, and you'll see why this theory is so exciting. It's actually an amazing duplicate of the stars. I don't know if the camera can pick it up clearly, but here is our Mars face area. Can I tilt it? Is it alright? It's alright, okay. All these stars fit by magnitude with basically the size of the anomalies. Even some of the other stars in contention here have anomalies matching. There's a grouping down here that seems to match that other grouping on Mars. But more importantly, let's see what star comes into the position of the target. Now we know that that target is directly in place. I'll take the transparency away. We'll now zoom in this area. So let's look at the target area. Under magnification, I'm going to lock in on this star and run back in time. Now we need to find what star is in this area as we go back into time. I'm going to run back in hundreds of years per second, starting now. Watch the small star. There it goes. Run back now, 1,000 years ago. That's 0 BC. Now we're going back to 3,000 years ago. Over here. 4,000 years ago. 5,000 years ago. So it's 4, 5, 6,000 years ago it's in that position. It's moved from there in the exact direction that we're anticipating. What's so important about this little star, this is our sun-like star that we're looking at, and it's 16 light years away, 15.74 to be exact. And this amount of time needed to get to exactly being in position is 17,000 years ago. In 17,000 years, it gets exactly into that position. That matches the Mars face. That is our conclusion. 17,000 years ago, that area on Mars was very, very important, and it seems to revere a sun-like star being a place of the gods, a place of humans colonizing this place on Mars. And this is more than likely in reverence of the colonization from that star. That's it.